So in the last class we've seen the LCR circuit. We've also seen the condition of resonance and the sharpness of resonance as well. So today we will be seeing the power in the AC circuit. The rate of energy dissipation in an electrical circuit is the power, and the power in the circuit is the product of voltage and current. Power P equals voltage V times current I. Thus, the power in an AC circuit may depend on the phase difference between the voltage and current. The instantaneous values of voltage and current we've already seen from the beginning. The voltage is given by instantaneous voltage is given by E equals E naught sine omega t, and the instantaneous current is given by I equals I naught sine omega t plus phi, where phi is the phase difference between the voltage and current. Then instantaneous power is given by simply multiplying the voltage and current, instantaneous voltage and instantaneous current. So instantaneous power equals E into I, where E is E naught sine omega t and I is I naught sine omega t plus phi. So using the formula sine A plus B, we can write sine A cos B plus cos A sine B, and just using that we can expand this sine omega t plus phi term, and then this becomes E naught I naught sine omega t, and sine omega t plus phi is expanded as sine omega t cos phi plus cos omega t sine phi, and this becomes E naught I naught. Taking sine omega t term inside the bracket, this becomes sine square omega t cos phi plus sine omega t cos omega t sine phi. Using the formula sine 2 theta equals 2 sine theta cos theta, this becomes instantaneous power becomes E naught I naught sine square omega t cos phi plus this sine omega t cos omega t can be substituted by sine 2 omega t upon 2. Using this formula, sine 2 theta equals 2 sine theta cos theta. Now, the average power over a complete cycle, complete AC cycle, is taking the average of this instantaneous value, we will get the average power over a complete AC cycle as half E naught I naught cos phi. You might already know the average of sine square omega t over one complete AC cycle is nothing but half by half, and average of sine 2 omega t equals 0. You can just verify this by using a graph plotting sine omega t, sine square omega t and sine 2 omega t over one complete cycle. And the average value of power can be written as E naught by root 2. This 2 can be written as root 2 into root 2, and E naught by root 2 times I naught by root 2 into cos phi. This E naught by root 2, as we have seen already, is RMS value of the voltage. I naught by root 2 is the IRMS into cos phi, and this cos phi term is known as the power factor of the AC circuit. Its value depends on the nature of the circuit. Now, concluding whatever we have seen, in a pure resistive circuit, we've seen voltage and current are in phase, so that phi equals 0 or cos phi equals 1. We've seen that current and voltage are in phase in a purely resistive circuit. Then P average will be this cos phi term becomes 1 since phase difference is 0 between current and voltage. So this becomes P average equals ERMS into IRMS into 1. So this becomes P average equals ERMS into IRMS. and this is equal to power can also be written in the form of I square R or I square RMS into R, and this can further written as E square RMS upon R. This you might already know different expressions for power. And now in a pure inductive or capacitive circuit, the phase difference between voltage and current is 90 degree. We know that either voltage lags behind current by 90 degree or voltage leads by 90 degree in the case of purely inductive or capacitive circuit. So the phase value will be 90 degree. Phase difference will be 90 degree, and substituting that in the average power value, this cos phi term will become 0, and then average power will also becomes 0. That is, the power dissipation in the circuit will be 0. This is the resistance of an AC circuit is 0. If the resistance in an AC circuit is 0, although current flows in the circuit, the average power remains 0. That is, this is the case we have discussed here. That is in the pure inductive or capacitive circuit. That is when there is no resistance, there is no external resistor, and there is only an inductor or capacitor. So in the case of if the resistance in an AC circuit is 0, although current flows in the circuit, yet the average power remains 0. That is, there is no energy dissipation in the circuit. The current in such circuit is called wattless current. In practice, however, wattless current is not a reality because no circuit can be entirely resistanceless. There will be some resistance associated with the circuit in practice. In LCR circuit, the power dissipation is given by P average is equal to ERMS into IRMS into cos phi. We've seen. Thus, the value must depend on the power factor, which is cos phi. And in LCR circuit, if XL equals XC, if XL equals XC, you've seen this is the condition for resonance, and the impedance is minimum. The impedance is minimum. And the circuit will be purely resistive. Hence, the current reaches its maximum. Impedance is minimum. That is XL equals XC, and this whole term will cancel. And only it's a purely resistive circuit. That is Z equals R. Impedance will be only due to resistance. Then the current will be maximum in such a circuit. The current will be E by R. And this condition is known as electrical resonance. So this is the end of our chapter. And we have seen in the previous videos different types of circuits. Initially we've seen direct current, and we've seen the decay of current in a circuit, and after that we've started alternating current, and we've seen different types of circuit like purely inductive circuit, purely capacitive circuit, purely resistive circuit, and we've also seen capacitive inductive circuit or capacitive resistive circuit, etc. And finally, we've seen the LCR circuit. We've seen the impedance value in the LCR circuit, and we have also seen the condition of resonance, which have wide applications like the radio tuning, which we have discussed in the class. And finally, we've seen the power in the AC circuit. Thank you.